All right, good afternoon, everybody. My name is Kadek, Pramana Jaya, and today I'm going to present about the system of linear equation into variables, commonly abbreviated as SPLDF in Indonesia. And we will learn how to determine the solution that satisfies the system. All right, next. In this section, we will explore various scientific methods to find the exact solution for a system of linear equation with two variables. Before we jump into two variables, do you still remember what a linear equation is? A linear equation is an open sentence containing a single variable raised to the power of 1 connected by an equal sign, which forms a straight line when it's graphed. For example, 3x plus 4 is equal to 10, and then 3x equals 9, equals 6, and x equals 2. When it's graphed into the coordinate Cartesian, it's going to make a straight line like this. All right, next. Uh, Now, what is linear equation into variable? A linear equation into variable is a linear equation that has two variables, each raised to the power of 1. The general form is ax plus by equals c, where a, b, and c are real number and a and also b are not equal to 0. All right. Did you know why can the value of a and b in the general form ax b ax plus by plus c cannot be equal to 0? Because if a and b are equal to 0, it will no longer be a linear equation. Instead, it becomes merely a mathematical statement and will have no solution. All right. Next, when we speak of a system, it means there are two or more linear equations in two variables presented simultaneously. The general form is a sub 1 x plus b sub 1 y equals c sub 1. Then sub 2 x plus b sub 2 y equal to c sub 2 is exactly the same as the previous one. All of them are real numbers, okay? And how do we solve a system of linear equation into variable? There are several methods that can be used to solve it, namely a graphical method, substitutional method, and elimination method. Okay, first is determining SPLDV, I'm sorry, solution with the graphical method. We're going to draw a straight line for both equation on the Cartesian plane, then determine their intersection point. So use a table or determine the intercept setting x or y to 0 for each equation to find the points where they cross the x-axis or y-axis. Next, for there's example problem. Solve the system of equation below using the graphical method. So the step one is how to determine the intercept for each equation. Like for the first equation, which is x plus y equal to 4, this means the straight line for equation 1 intersects at the x-axis when the x is equal to 0, the y equals 4. And when the y equals 4, the x equals 4. So the x-axis at 4, 0 and the y-axis at 0, 4. All right. We're going to do the same thing for the second equation. So next. The step 2 is plot the points passed by each equation on the Cartesian plane. And then the last one is find the intersect point where the two lines crosses on the graph. And this is last one, I'm sorry. The intersection point x, y on the two lines is the solution or the answer for both equation. The two equation intersect at the point 2, 2. Therefore, the solution for this SPLDV is 2, 2. All right, next. Determining SPLDV solution with the substitution method. Convert one of the equation into an explicit form, then substitute its value into the other equation. Here's some example for an explicit and implicit equation. An equation form that matches the linear function form is called explicit, and the general form of a linear equation into variable is called the implicit one. For here's some example problems. Solve this system of equation below using the substitution method. We're going we're going to convert equation 1 into the explicit form x equals cy plus d, right? It's from x minus 2y equals 8 become x equals 2y plus 8. Next, we're going to substitute the value of x equals 2y plus 8 into the equation 2, and it's become like this. Next. In step 3, we're going to substitute the value of y, where it's equal to negative 12 into equation 1 or equation 2. It is found that the value of x equals negative 16 and y equals negative 12. So the final solution for the SPLDT above is negative 16 comma negative 12. All right, the last one we have the elimination method. So eliminate one of the variable from the equation. If the coefficient of the variable we eliminate are not the same, multiply the equation by a certain constant to make a more both coefficient equals. First, to determine the value of variable x, we're going to eliminate the variable y, and then to determine the value of variable y, we're going to eliminate the variable of x. Here's the example problem. Solve this system of equation below using the elimination method. First, we're going to determine which variable to eliminate. Eliminate variable x to determine the value of variable y. Step 2, make the coefficient of variable x the same for both equation, then eliminate by subtracting uh, the two equations. And step 3, repeat the step 1 to determine the value of x by eliminating variable y. And then the last one is make the equation of variable y the same for both equation, then eliminate it by substituting the true equation. Therefore, it's found that the value of x equals 6 and y equals negative 2. So the final solution for the SPLDV above is 6 comma negative 2. In your opinion, which is the right method to solve an SPL defeat? It depends on the problem presented and the ability to apply the solution method. All right. Here's some equation that I would like you to give it a try. Determine the solution for the following system of equation. The first equation is x n- minus 2y equals 9, and the second equation is 2x plus 4y equals to 6. Solve it using the method you find is the easiest. And here's the summary. There are three methods or ways to solve an expeditive. First, a graphical method by drawing lines from the given equation, then determine the intersect point of both lines. And the second one is substitution method by replacing the value of one variable with another equation that has been converted into explicit form. And the last one is the eliminating method, which is eliminating one variable to determine the value of the other variable. All right. All right, that's all about my presentation. Thank you very much for your attention and goodbye.